Today's lecture goes over section 6.2, modeling with cubic and quartic functions. In this class, we've already did linear regression and quadratic regression. So today we're going to move to functions whose has a degree of 3, which aligns with the cubic function, and those that have a degree of 4 with the quartic function. We're going to be using graphing calculators, and this is going to enable us to find cubic and quartic functions that model nonlinear data. In this section, we will model and apply these functions. We're going to be using the graphing calculator to create a formula and then use the graphing calculator to model both cubic and quartic functions. Today's lesson comes from page 440 in your electronic textbook. If you have not looked over section 6.2, pull up your MyMathLab account. Look to the left and you will see a link to your electronic textbook. Go to section 6.2. All of the material that I will be covering today comes from this section. If you remember from previous examples when we were doing linear and quartic, not quartic, but quadratic regression, we would always go to the stat function on our calculator. We're going to be going to the same area to find cubic and quartic functions. We're going to hit the stat button, then we're going to go to calc. And this time, instead of doing 4 for linear regression or 5 for quadratic regression, we're going to go to number 6, which is going to give us our cubic regression. Remember, cubic are 3s, so we have a degree of 3. And also quartic regression, quartic being 4. An example of a cubic function looks like this. Y equals a x cubed plus bx squared plus cx plus d. So the highest degree is a 3. So I'm going to write down the specific steps in your calculator so that you'll have it in your notes. So make sure that you print out your notes for section 6.2 and write along as we go. So again, number 1, you're going to go to Stat. You're going to hit the Edit button. This is going to give us a chance to put in our data. Remember that L1, we're going to put in our X's, and L2, we're going to put in our Y's. Then we're going to go back to the Stat button. You're going to hit Calc. And for cubic regression, again, we're going to hit number 6. If you do not have your TI-84 calculator or you don't have a graphing calculator with you, do not forget that you can go to Google and you can download a free app, the TI Virtual Graphing Calculator. Just put in Google Virtual TI-83 Calculator and download that. And you can use it for all of the material that you'll need for this course. After completing the cubic regression, it's going to give you the standard form again. Y equals ax cubed plus bx squared plus cx plus d. And all you have to do is plug in the coefficients for A, B, C, and D. All right, so let's look at an example. The first example that we're going to talk about, the data is given. It says, given the data in the table, find the cubic function that models the data in the table. We want to make sure that we round to 3 decimal places. Just like in our example, it's very important when you're doing your work online that you also pay attention to the decimal places that it's asked you to round to. So let's pull up our graphing calculator. All right, so I've got my graphing calculator and I'm going to enter this data. So we're going to follow the steps. We're going to go to Stat. Okay, so let's look at this example. We're going to pull up our TI-83 graphing calculator. We're going to go to Stat. We're already at edit, so we're going to hit enter, and we're going to enter our data. So our x values are 1, 2, 3, 4, 5, and 6. All right, our y values we're going to place in L2. We're going to begin with -1. The data is a little bit harder to enter on my laptop for you guys. I noticed I had to hit everything twice just to get to use my little laptop. So y'all bear with me. All right, so once we enter our data into L1 and L2, we're going to go back to Stat. We're going to arrow over to Calc. And then you can see that number 6 is cubic regression. So let's hit number 6. And we're going to hit Enter. All right, so it's going to give us our coefficients. We're going to round to 3 decimal places. So in this particular example, A is 0.287. B is -2.246. C is 6.181. And D is -5.333. Now let's pull up the graphing calculator so we can make sure that we've rounded correctly. The A value is 0.287. I look to the right, so since that's 0, that's going to stay as 7. I look at the third decimal place for B, which is a 6. I look to the right, that is a 0, so that remains a 6. I look at C, the third decimal is a 1, so I look to the right, that's a 2, so that's also going to stay a 1. And -5.333, I look to the right, that's a 3. So since that is not higher, 5 or higher, that also stays a 3. So I've got my coefficients. The last step is just to plug it into our formula. So y equals 0.287 x cubed minus 2.246 x squared plus 6.181 x minus 5.333. You'll see that part B wants us to take the same data, but this time they want a linear function. We did this previously. So we've already got our data in our L1 and L2. So we're going to go back to Stat. We're going to go over to Calc. And we're going to do number 4, which is linear regression. And so it's going to give me my coefficients for A and B. Again, we want to round to 3 decimal places. So if I look at A, the third decimal place is a 7. So if I look to the right, we know that that's going to stay as 7. In the part of B, the third decimal place is a 6. When I look to the right, that is a 6. So I'm going to round that to a 7. I'm going over this because in class I noticed that some students are still having problems rounding. So our coefficient for our A value is 2.457. The coefficient for my B is -5.267. If you recall, a linear function looks like y equals ax plus b. So we're just going to plug that in. Y equals 2.457x minus 5.267. So I'm going to pull the calculator back up and you can verify that data. Part C says to view the scatter plot in your graphing calculator and determine which function is a better fit for the data. So we have some data. We've created a cubic function and a linear function, and we want to know which one of those best represents the data that we were given. So if we want to look at the scatter plot, of course, the first step is to turn your scatter plot on. So you can see that when I went to scat plot, and I look at number 1, it's off. So I want to turn that on. So we're going to turn on our stat plot. Now I'm going to go to y equals, and I'm going to put in my cubic function first of all. Okay, and now we're going to select Zoom 9. You can see that there is our data that we've listed. And I want to go back and look at my function. Okay, I had to pause the video for a second because there was an error when I keyed in my formula. Some of you may have noticed that. I sure miss you in class when you could have told me that. So you guys bear with me on this first lecture. What's happening is when I'm using my virtual calculator, in order to enter any data, I have to hit that key twice. So it's taking a little bit of time getting used to that. I had forgotten my x variable in my y equals. So I went in and I keyed that in correctly for you. Now I'm going to hit Zoom 9 twice. You can see that there's our data because our scatter plot is on, and our cubic function aligns very good with that. So it also wants to know, well, does the linear function, that could be a better example. We can see that the cubic function is pretty accurate. So let's go back to y equals, and in y2, or actually, I'm just going to clear this out for you, and let's put in our cubic function, which was all right, and so let's hit graph. You can see that the linear function is not a very good example of that. So definitely our cubic function is best. All right, let's move on to the next example. Page 2. Example 2 deals with diabetes. In your textbook in table 6.5, it shows the number of U.S. adults with diabetes, which is projected to increase rapidly in the future. The projected numbers for selected years in millions is shown in the table. Use your calculator. Create a scatter plot of the data where X equals the number of years after 2015. So remember, we're going to have to align our data. And Y equals the number of millions of US adults with diabetes. So the first thing that we're going to do is we're going to align our data. Since X is the number of years after 2015, we're going to take all of our values for our X and we're going to subtract it from 2015. So 2015 minus 2015 is 0. 2020 minus 2015 is 5, 10, 15, 20, 25, 30, and 35. So we're going to create a scatter plot of that data. So the first thing I'm going to do is I'm going to go back. We're going to clear our calculator. I'm going to go to Stat. I'm going to go to Edit. I'm going to clear out L1 and L2. Remember, if you go up to L1 and you hit your clear button, arrow down, it's going to clear out the whole thing, so you don't have to go in and clear out each individual. Okay, so let's put in our align data. So we've got 0, 15, 20, 25, 30, and 35. So I'm going to take just a second. I'm going to verify my data. All right, so 0, 5, 10, 15, 20, 25, 30, and 35. Okay, so now let's go to L2. We're going to put in our millions. You should be following along in your calculator as well. Okay, so create a scatter plot of the data. So we're going to go back. We're going to make sure our scatter plot is turned on. All right, it's on, so we're going to zoom 9. All right, so there's our data. It says create, in part B, create a linear function that models the data. So they want us a linear, okay? So we're going to go back to Stat. We're going to go to Calc, and we're going to hit number 4 for linear regression. You can see that they want us to report the model with 3 significant digits. So we want to make sure that all of our data contains significant digits. If we have a bunch of zeros in there that are insignificant, we're not going to worry about those. So in this case, all of these digits are significant. So y equals ax plus b is the form of our linear function. In this case, a is going to be 1.736, b is going to be 40.508. So pulling back up the calculator to verify my rounding, if you look at the third decimal place, which is a 5, we look to the right, so that is going to round up to a 6. 508, 8 is going to stay the same. So our linear function is y equals 1.736x plus 40.508. Now it wants us to take that same data and we're going to create a cubic function. And we're going to report with 3 significant digits. Okay? So we're going to go back to our calculator. We're going to go to Stat. We're going to go over to Calc. And we're going to go down to number 6 for our cubic function. All right, take a moment. It says e to the negative 4. We know that is in scientific notation. That means that I'm going to move my decimal 4 places to the left. So in this case, a is going to be, now pay attention to that, this negative 4 tells me that's in scientific notation. You're going to move your decimal places, 4 places to the left. So if I move it 1 time, that's going to leave me with 3 more decimals. So a equals 0.000696. Okay? We need 3 significant digits. These first 3 digits are not significant, so we want 3 digits after those zeros. So we're going to stop with the 6, and I'm going to look to the right. Since that's a 9, we're going to keep our a value at 0.000697. Look at our b value. Our b value is negative 0.048. We want to round to the third significant digit. So that 8 is going to round up to a 9. So b is going to be negative 0.049. C is going to be 2.636. And our d is going to be 37.489. Going back to the calculator, our C, 2.635, I rounded up to a 6 because that was a 9. 5 or higher, we rounded up. 37.489 stays a 9 because the number to the immediate right is a 3. Again, 5 or higher, I would round up. So our cubic function is going to be this. Y equals 0.000697 x cubed minus 0.049 x squared plus 2.636x plus 37.489. It wants us to graph the data on the same axis as each model and determine which is the better fit. Is it going to be the linear function or the cubic function? So we go back to our calculator. We're going to enter all of this into our calculator. Take this time to enter the data with me. Okay, There's my cubic function. I'm going to arrow down, and I'm going to put in my linear function. It doesn't matter which one you put in, y1 or y2. We know that the linear function is going to be a straight line, and the cubic function is going to be curved. Okay, let me double check my values. 1.736x plus 40.508. All right, so we're going to zoom 9. Can you tell which one is the cubic function and which one is the linear function? That linear function is the straight line. You can tell that the cubic function hits those data values right on. So in this case, the cubic function better represents that data. Part E in our example says, in which year will the number of millions of Americans with diabetes reach 7 million? Now go back and look at your data. Our X values are the year, and millions is the projected number of people with diabetes. So they're asking us in part E, in what year? So they're asking us to solve for X. It tells me that the number of people with diabetes is 70 million. So we're going to use our cubic function because it was a better representation of our data. So I'm going to write that cubic function one more time. We're trying to solve for X. We want our Y value, which is the number of people with diabetes, to be 70 million. All right, so if you'll recall for our calculator, we're going to put Y1 in as 70, Y2 will be our formula, and we're going to do an intersect on that. So let's go back to our data. Since I already have that in Y1, I'm going to put 70 in as Y2. Okay, so to solve this, we're going to do an intersection. So if you recall, we're going to go up here to the top above trace. We're going to do the calc. We're going to do 5 for intersect. And we're going to hit enter 3 times. So our intersection is 16.015. That rounds to 16. So X is 16, but remember, X was the number of years after what? After 2015. So 2015 plus 16 is 2031. So when will the number of years, in what year will the number of people with diabetes be expected to reach 70 million? In the year 2031. All right, so let's move on to another example. Again, this comes from your textbook. Table 6.4. It says use the data in table 6.4 to answer the following questions. Find a cubic model that gives the number of Americans working full-time as a function of their age X. So again, age is going to be X. The number of millions of people working full-time is going to be our Y values. We're going to round to 3 significant digits. So of course, the first thing we want to do is to enter our data into our calculator. So I got to go and clear out all the stuff from the previous example. So let's clear it. All right, so in L1, we're going to enter our ages. So let's take a moment to do that. 27, 32, 37, 42, 47, 52, 57, and 62. Give me just a moment. I want to check my data. 27, 32, 37, 42, 47, 52, 57, and 62. I'm being extra cautious with the data. All right, in L2, we're going to enter the Y value. Recall that the Y value stands for the millions of people working full time. So let's enter this data. Okay, so double check your data, make sure you've entered it correctly. It wants a cubic function. So we're going to go back to Stat, we're going to go over to Calc, we're going to go down to 6. We want 3 significant digits. So look at the very first A, 3.616162 e to the negative 4. That e to the negative 4 tells me that it's written in scientific notation. It tells me again that I'm going to move my decimal places 4 places to the left. So that means that I'm going to move it 1 place. It would then be in front of the 3, and then 3 more times would give me 3 zeros. So A would be negative 0.000362. Pulling back up the calculator. All right, I need 3 decimal places. So 3, 6, 1. 1 would be my third decimal once I've moved my decimal place to make it significant. When I look to the right, that's a 6, so that's why I've made the 1 a 2. Our B value, 040. The C value, negative 1.389. That's going to round up and become 0.390. And D would be 21.679. That's going to stay the same. So I'm going to write these coefficients out for you. B, 0.040. C, negative 1.390. And D is 21.679. So plugging it into our cubic function, we're going to replace our coefficients. So the cubic function modeled by this data is negative 0.000362 x cubed plus 0.040 x squared minus 1.390 x plus 21.679. Part B wants us to graph the unrounded model from part A on the same axes with the data. And let's comment on the fit. So we're going to go back. We're going to put our data into our calculator. Okay, so we're going to zoom 9. Let's see if this data can be represented well by our function that we've gotten. Let me check my data. Okay, so I had to go back since it did not match up, and I reviewed my data that I had put in Y1. You can see that I put a 1 instead of 21. So let's correct that. Now let's try it again. You can see that I have one more error here. So let's correct that. Yes, I missed you telling me in class my errors. Now I'm having to figure it out by myself. Okay, so I've corrected, hopefully, all of my errors. Look at there, third time's the charm. Put in all the data. It's a pretty close fit for our data. So we would say that it's a pretty good fit. Okay? Our next question asks us, use the model to estimate the number of Americans working at age 59. Go back up here and look at your data. Age is X. So they want us to estimate the number of people working full time when our age is 59. So when X is 59. So all we're going to do there is we're going to take our function and wherever X is, we're going to replace with 59. So Y equals negative 0.000362 times 59 cubed plus 0.040 times 59 squared minus 1.309 times 59 plus 21.679. So you should go to your calculator and we could just put in that information. And when you get that, you get 4.56. So the estimated number of Americans working at age 59 would be 4.56. Remember, our data is in millions. Okay? The last thing that we're going to talk about in this lesson deals with quartic functions. So I'm going to write out the standard form for a quartic function. The difference between cubic and quartic is, of course, that the degree for a quartic function is 4. So y equals ax to the fourth plus bx cubed plus cx squared plus dx plus e. So the steps in our calculator are going to be very similar. We're going to go to Stat. We're going to go to Edit. In list 1, we're going to put our x values. In list 2, we're going to put in our y values. Then we're going to go back to Stat. We're going to go to Calc. And this time, we're going to hit number 7, which is quartic regression. And finally, we're going to plug in our coefficients for A, B, C, D, and E. So very similar. So let's look at an example of a quartic function. It says find the quartic function that is the best fit for the data in the table below. So we're going to go back to our calculator. I'm going to clear out all of my data. So I'm going to go to Stat and I'm going to go to Edit. I'm going to clear out that data. And I'm going to re-enter the data for this example. So we're going to enter our values for x. So we've got -3, and L2, All right, so we've entered our data. Find the quartic function. So we're going to go to Stat, over to Calc, number 7 for our quartic function. Okay, and to keep things simple, okay, so I had put 5 in instead of 55. So let's relook at that quartic function. Okay, so A is 1, B is 0, C is -4, D is -3, and E is 1. So we're just going to, A is 1, B was 0, C was -4, D was -3, and E is 1. So we're going to plug it back into our standard form. The idea here is that we can take the data and we can represent it with different functions. However, there is a best fit that works better. Sometimes the cubic function represents our data better. Sometimes the linear function does. Now we know that we don't need to write that 1 in front of that x to the 4th. 0 times x to the 3rd is just 0. So that's going to remove that term from our equation. So our quartic function will look like this. The final comment for this lesson says, in this lesson, many of the questions on MyMathLab ask for cubic and quartic functions. Some of the questions ask for linear or quadratic. Either way, all of these, you're going to go to Stat, and then you're going to go to Calc.